seal this stuff out. We don't have to smell it anymore. There we go. All right. We're right there. This is an oxidation reduction reaction. The last thing that we have to add is our reducing agent. We have to add a reducing agent. That reducing agent is going to be sugar. So what we're going to do is you're going to dump in your sugar solution. Then after you dump in your sugar solution, you're going to put your cap on. And after you put your cap on, we're going to shake these things like crazy and hope they don't explode. Alright? So you're going to dump it in, put your cap on tight, dump it in there, and get your cap on tight. Then we got to start shaking. Alright, get it tight, 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 tight. Go, 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 go. Shake, 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 shake. Turn it right upside down. You got to get it up at the top. Shake, 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 shake. Sideways like this, you got to do it like that. You got to do it like this over here. Okay. Then back like this. Then right upside down again. You know, the harder we work, the better this is going to look. So we got to shake in all directions, every way you can. Every way you can. You got to put it behind your head. That's always good. Do it. Then you got buddy hop. You got buddy hop. You got to do it till it's exposed. Don't stop shaking. Quick, quick, quick. Go, 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 go. Shake, 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 shake. Don't stop. You got to keep on shaking. You can see what's happening. We're making it inside. Don't stop shaking. Don't stop shaking. Inside our bottle, our silver is turning into silver metal, a mirror. I'm going to talk to them for a minute. Don't stop shaking, okay? All right, so keep shaking all directions, back and forth, left and right, over and under. Inside our bottle, our silver is being reduced to silver metal. We make a silver mirror. Now, the question I have is, why do we make mirrors out of silver? There are lots of shiny metals out there that are cheaper than silver. Why do we make them out of silver? Has to do with silver's reflective properties. Silver is not even a really good mirror. It doesn't reflect all the light that strikes its surface uniformly. Some of the bluish colors get faded out. They get washed out. So when we look at ourselves in a silver mirror, your skin tones have a nice, healthy, pinkish glow to them because of the fading of the blue colors. So we make mirrors out of silver for one reason: vanity. You literally look better in a mirror made out of silver than you do a mirror made out of any other metal. So the next time that you look at yourself in a silver mirror, just remember, you don't look that good. Because what I see is not what you see. That reflection is not truly what you look like. All right, so it looks like our bottles have worked out well. What we have to do now is clean these out, except we don't have a funnel. What's that? We can do it. I'll just do it. All right, so what we want to do now is we're going to rinse these out. We're going to add a little water to clean them out. Put some water in there. Put your top on and shake it around. Put your top on and shake that baby around. Rinse it over into here. Alright, rinse that around. One more little drip. Just swirl that around in there. Get our solids out. And now we have an official silver mirror bottle. You can have that now as a souvenir of coming to Clarkson University. What you want to do is let it dry for about an hour. Leave the top off. Let it dry for about an hour. Then seal it up afterwards. As long as you leave it sealed, it will stay silver. If you take the top off, it'll tarnish just like grandma's silverware and it'll be an ugly brown. But let it dry for about an hour, and then cork it up, leave it corked, and you can have that when you come to Clarkson University as a chemistry major in 12 years. All right? Okay, great, thank you. All right, now, in surviving agent, you get the, there you go, all right. A real nice brother would give it to you. Brother. Oh, okay. So you don't have to give him anything. All right. let's go here. Now, afraid it's going to be hard to surprise you on this one. I always tell my students that I don't do gratuitous demonstrations. Every demonstration I do in my class, and these are all part of my general chemistry course, all have something to do with the topic that we're discussing at hand. So one day a year that I do a demonstration solely for the day. I want you to guess what day that is. And although I did it just a couple of days ago in this room, there probably aren't many surprises left here. But you have to guess what day I do this demonstration. All right. So, what day of the year do I do this demo? Shamrock of chemistry, St. Patrick's Day, boric acid, when mixed with methanol, for what are called borate esters, which burn with a brilliant green flame. That green flame is a result of the combustion of those esters. And so on St. Patrick's Day, we do the flaming green shamrock of chemistry, just to demonstrate that fact. All right, thank you very much. Woo. All right. Are we running out of time yet? You guys got anywhere to go? You seem to like chemical reactions that give off energy, that are exothermic. So here I've got a mixture of iron oxide and aluminum. Iron oxide and aluminum, these are two powders. The mixture is commonly called thermite. Now, when these two materials react, there's a tremendous amount of energy released. How much energy? Well, let's find out. To ignite this mixture, I'm going to use a fuse, so I don't have to be in the neighborhood. This is a small piece of magnesium. Now, in this flower pot, I've covered the hole in the bottom with a piece of paper. Let me tell you what's going to happen so you don't miss it. The iron oxide and the aluminum are going to react together, and it's going to release energy. It's going to get hot. It's going to get so hot that the iron produced is going to rise above its melting point, and it's going to melt. When it gets to the hole in the bottom, it'll burn through the paper, and you should see a column of molten iron pour from the bottom of the bucket. So, let's check out. Let's get our magnesium going here, and you watch the bottom here. That reaction releases so much energy in such a short period of time that the end product, make sure this is done dripping on me, the end product is a red-hot chunk of molten iron. And this reaction can be used to weld metal together. It can be used to cut metal apart. It gets so hot that it can actually melt iron. You can see just how hot that is by putting it in water. That the total amount of energy, the amount of energy released in that reaction was enough to melt that chunk of metal. You know how much energy that was? That was almost as much energy as your body gets when you eat a Snickers bar.